Hi all. Today we are gonna talk about Newtonian mechanics, uh, which is also called classical mechanics. So Newtonian mechanics or classical mechanics is basically applied to macroscopic particle. It is basically divided into two parts: kinematics and dynamics. So what basically Newtonian mechanics deals with? It deals with what are the various attributes of that macroscopic particle, like what is the velocity of that macroscopic particle, acceleration, displacement. This study is called kinematics of the particle. On the other hand, dynamics deals with why. Here we will talk about gravity. The very basic objective of this Newtonian mechanics or classical mechanics, the idea here is to predict the future or the past given the present is known. Like if the velocity, acceleration, displacement is either of them is known, one can predict using Newtonian mechanics what is going to be the next state of that particle, where that particle is going to be if you throw a particle from one point, where it's going to land. uh, so macroscopic particles are generally those particles which are tangible and which doesn't travel at the speed of light, or which are not very small to be governed by the law of quantum mechanics. So what we will do, we'll consider a frame of reference. This is x, y and z. This is minus x, and we'll to study Newtonian mechanics initially we will use only one dimension. We'll consider a particle at this origin point 0 0 0, and we'll say that the particle will move in positive x direction, then it will go back into its origin, then it will go in the negative x direction, then again come back to 0. So this is the behavior of the particle. It goes from this point to this point to back to this point and again back to its origin. So if I make its xt curve, or represent the motion with respect to time on x-axis, so I can say the particle has moved like this, then it has gone down in the reverse direction and then back to the origin. This is x0, and let us say this is x1. So Newtonian mechanics, there are certain concepts which we will go through right now, like what is the distance traveled by the particle. So the distance is the entire perimeter of this curve. If you put a small wire over this and then you measure the length of that wire, that is the entire distance. However, there's another concept called displacement, which is the difference between the final position and the initial position, that is x1 minus x0, which is also called delta x. So if a particle starts from here, goes to this point, so the displacement would be this minus this, this minus this. In this term, in this case, when the particle has started from here, gone all the way from here to here and again here, since x0 and x1 are same, that means displacement is 0. However, there is certain distance which the particle has traveled. Another concept is speed. Speed is the rate of change of distance, or distance divided by time. It is measured in meter per second. There's one more concept which is called velocity, which is the rate of change of displacement divided by time. So if a particle starts from here, goes all the way up to this point, and we want to find out, and let us say this point is x1 or x2, we want to find out what is the velocity here. So we will say x2 minus x1, that is the displacement between origin and this point, divided by t2 minus t1, or not x0 and t0. So time at this point is t0 and this point is t1. So x2 minus x0 and t2 minus t0, which can also be written as delta x by delta t. So if we, it is very clear that if you want to find out the velocity, you need two very different points. But let's say you want to find the velocity at any given point only. In that case, you need to take a infinitesimal small section of this graph and differentiate it. Here you need to use the differential equation or the derivative like this, which we'll not see in this video. We'll do another video for that. But for our case, we'll consider, since we are only dealing with algebraic equation, we'll go delta x by delta t. There is another concept called acceleration, denoted by a, which is the rate of change of velocity with respect to time. So let us say this is x3. At this point the velocity is v3. At this junction the velocity is v2. So this will be v2 minus v3 divided by t2 minus t3. It can also be written as dv by dt, and if I substitute dx by dt as a value of v, acceleration can also be written as d square x by dt square, or the second derivative of displacement and the first derivative of velocity. Now if we only consider this much equation, and let us say we take these 2 points here, this is, we want to find out the acceleration in this region, and let us say at this point the initial velocity is u and the final velocity is v. So acceleration will be u minus v divided by delta t, where delta t is this region. From here you can find out that v is equals to u, this is v minus u, so v equals to u plus a delta t. This is Newton's first equation of motion. Similarly, if we analyze this equation again, so this equation says that if we make a velocity versus time graph, we will say initially the velocity is u, and then you've accelerated it to a point v. So in a velocity time graph, the area under the curve gives us the distance. So what is the area under this curve? If we divide this curve like this, and this is time t, acceleration, the distance would be area of this rectangle, that is u times t, plus area of this triangle, that is half t times v minus u. Now if I substitute the value of v from equation 1 to this equation, it will give me ut plus half t u plus at minus u, and if I solve it, it will become ut plus half at square, as this and this will cancel each other. So this is the second equation of motion, Newton's second equation of motion. Now from this equation we can say time is v minus u by a. If I substitute this time to second equation, I'll get s is equals to u v minus u by a plus 1 by 2 a v minus u by a whole square, which can further be written as uv minus u square by a plus 1 by 2. This a and the square of this a will cancel each other, become by 2a, and on the numerator we will get v square plus u square minus 2a minus 2vu. On further solving this, we'll get, if we take 2a in the denominator, we'll get 2uv minus 2u square plus v square minus plus u square minus 2vu. S is equal to. From here we can see that this term and this term will get cancelled, and you will end up with s equals to v square minus u square by 2a. So here we can say v square minus u square equal to 2as, and this is the third equation of motion. So equation 1, which is v is equals to u plus at, this tells us that if you know the initial velocity and you know for how long acceleration is provided, you can find out the final velocity. The second equation, s equals to ut plus half at square, tells us that if you know the initial velocity and the acceleration and the time of acceleration, you can find out what is the total distance which it has covered. And by the combination of these two equations, we can get v square minus u square equals to 2as, which directly relates what will be the distance or the acceleration if velocity has changed from one point to other point, provided either the acceleration or distance is known. So these three equations together are known as Newton's equations of motion. And believe it or not, scientists just need these three equations to send a man to moon. These three equations are the bedrock for the Industrial Revolution. So that's all on the very first presentation on Newtonian mechanics. Thanks.